Discussing the ideas of an identification system, and we thought wouldn't it be easier if, for example, in checkpoints, someone would drive up in their car and the identification system would be able to immediately identify them, give you the relevant information about the car, license plate, VIN number, and immediately the person would be cleared and would be able to pass the checkpoint. So we wanted something that would make this efficient and faster, so we came up with the need to use biometric information, because it's you don't need someone to give you their driver's license or their national ID, and you don't need to run it through a computer. It's an automated system, so for the most part, you would only need an agent there, a human agent from the government, to be present, just to make sure that the system is running without fault. That just as a secondary confirmation that everything is as the identification system says it is. So the requirements we came up with for the system was it needed to be non-invasive, the least amount of interaction for the user or for the consumer, so that the person wouldn't be affected by the identification system, they wouldn't be inconvenienced by it, as well as the government itself. We wanted to make sure that they wouldn't feel the need to increase the number of agents present just to improve security or to make sure that nobody slips by. So we chose the biometric identification based on several different variables. We wanted to make sure that it's non-invasive, that it's accurate, and that it's reliable. So in the beginning, we found that iris recognition was the most commonly used because of its reliability and the least amount of time it needs. So we wanted to use that, but iris recognition, it had complexities and certain requirements that with our current budget we could not obtain the scanners required. So we chose facial recognition as the second most reliable and least invasive. So we built our project based on facial recognition with a secondary method of identification that was to be fingerprints, but also again to budget requirements we couldn't obtain that. So our system runs based on a recognition system and a back system that is the database that contains the user information, the social security number, the car license plate, the VIN number for the car, the address, all the relevant information for the person. The system's response time, even at the maximum capacity, which we calculated to be about 30,000 identification requests per hour, was to be no more than 15 seconds for maximum efficiency, so that to reduce inconvenience for the users. The system is to achieve zero false positive, which means it would never identify someone positively if they weren't that person. That was one of the main requirements. So it would never say this is Ahmed while he's Muhammad, for example. We also wanted to make sure that the false negative, where that it would say you aren't in the system while you actually are, would be no more than 10%. The ratio is not directly related, but when the false positive increases, so the false negative decreases, because you will always be identified, but at the risk of someone being identified when they aren't in the system. So in order to increase the accuracy, there is a risk of insult. It's referred to as the insult rate, where you would be refused while you are actually in the system. Now, we wanted to make sure that also the system would be platform independent, so the user can use their phone, their laptop, their computer. They wouldn't need an actual device to install the software on, or so that you can always run it from anywhere. We wanted to also make sure that the system would be adaptable, so that you can learn, so that, for example, if someone wears glasses or if someone starts growing a beard, the system would be able to update itself and relearn based on a variation of images that will be stored in the data set. Now, in the communications between the servers, we wanted to make sure that it would be most secure. This will be handled in the technical aspect of the presentation.
I think we should move on to the next.
Yeah. Now, we also needed to come up with a business case. How would this be used? How would this generate a profit? So the business model is that it would be a one-time sale originally to the government, where they would obtain the system, and then they would have a minimum of 2 weeks training period where we would train the employees or the agents and operators so that they would understand how to operate the system properly, how to enroll people, how to modify information. And after that, we came up with the concept of maintenance and support. So the system, the data centers where the servers will be running will need maintenance, code will need to be updated, the security issues will need to be addressed, possible bugs might arise, so that will need to be taken care of. So we created the maintenance would be like a guarantee when you purchase a new product. So 1 year free period, and then after that it's running cost. And then system upgrades, depending on technology, new technology arriving and all that, we would upgrade the system. Possible expansions to the system, using it in more places in different areas, and consultation services. This would be open for private organizations that would be that would want to run a smaller version of our system. So we would provide them with a version of this, and training workshops so that anybody that wants to learn about our system, they can purchase this. Now, this is a model of our data distribution, how we visualize the data of the person will be distributed. Now, the data distribution is more about the local level first, and then sub-regional level, and then regional level, and then national level. The local level is mostly cities or areas of cities, so we can divide a particularly large city into smaller areas in order to make sure that the node itself does not contain more than 5,000 people, to make sure that the model for the algorithm is not overloaded. After that, it goes up to the sub-regional level, where it would collect models from different local nodes. Depending also on the size of the region, would determine the amount of sub-regional nodes, and then goes up to the regional and the national level in the same concept. So this is the search procedure if someone is traveling, so that we would be able to identify them. So this is the node where the person's information is to be collected, right? Now, if the person is not registered in this area, so if they came from a different area, now this node would trigger a search into the immediate neighboring nodes, so that if the person is located in any of those, these nodes would immediately identify him based on the models that they already have, and they would forward his information. Now, if the person is not available in any of these nodes, the local node that he has been identified at will send it up to the sub-regional node. If he's not identified at the sub-regional node, it will immediately be sent to the national node to be identified there, in order to make sure that it doesn't take a long time.
Unfortunately, you have to round it up.
Okay.